Hello NCU students. Welcome to week 1 of our first week together. Well, one of the things I like to do before beginning the week is to identify the learning objectives for this week and then hit some of the highlights. So here we go. This week we have a number of learning objectives from chapters 1 and chapter 2. And this week those objectives include examining your values in light of statistics. Yep, I bet you didn't hear that coming or think about that one coming at you, did you? We're going to look a little bit about something called Bloom's taxonomy. I'll talk about that in a second. One of the other learning objectives is to be able to demonstrate basic understanding of the key statistical concepts. Comparing the basic definitions of the two branches of statistics is what we're also going to be looking at that this week. And then evaluating the proper use of charts and graphs in your business. You know, when you think about statistics, you may not think about your values or its cousin, ethics. Statistics is not void, if you will, of values and ethics. Studying statistics ought to challenge your mind, not just mathematically, but a deeper root in us, our values. I'm not going to cover it here, but please watch the discussion on Bloom's taxonomy in the attend section for week 1. Okay, we're going to hit this week some very basic definitions and some key statistical concepts. The first one we're going to look at is called population. Population is defined as all members in a data set that we want to study. So let's say for this example, I'm going to build an example for the next few minutes here. I want to study all the students taking statistics in the MBA program. All right, so that's our population. Next is our sample. And sample is defined as members in the population that we are selecting for the study. So by studying just a sample from the population, we can reduce our sampling cost and data collection time and arrive at conclusions about the population that we can study later on. So for example, in the example I'm building here, let's say that the population of students taking stats in the MBA program are divided into 3 sections. Let me pull that up here so you can see it. 1, 2, and 3. And so we've got my section, we've got other sections, we've got Dr. Vicha's section. And for the sake of this discussion, let's just say we're going to sample my section. If I can find it again. There we go. We're just going to study my section. All right? So my section is going to be the sample. Well, now let's talk about what a variable is. We're going to study a particular characteristic or an attribute that we are interested in. Now let's just say we want to better understand the GPA, the overall GPA that is, of students taking statistics in the MBA program. So we're going to study that variable in our sample of the population, which is a section, which is my section of students. Now we're going to look at this idea of parameter. Parameter is the specific measurement of the attribute that we want to know more about. So in our example, we want to know the percent of all students who are taking statistics in the MBA program who have a GPA higher than, let's say, 3.90, and we're going to study our sample to learn the answer to that question. Okay? So we're going to study my section. We're going to study the students in my section. We're going to look at their overall GPA. We're going to see which ones are higher than 3.90. And we're going to see if we can learn something about the entire population. Let's talk about that word statistics now. All right. Statistics is the specific measurement of that attribute in the sampled members. So in our example, we're going to study the percent of students from my section taking statistics in the MBA program who have a higher GPA than 3.90. Now, because we want to answer this question, let's see if I can get it pulled up here. There it is. What percent of all students taking statistics in the MBA program have a higher GPA than 3.90? Right? That's the question that we want to arrive at. But we don't want to sample everybody in the whole population because that could be too many, all right? Now, in our simple example, it wouldn't cost us that much, but you can imagine on a nationwide basis, it'd get expensive to answer that kind of a question. Well, let's talk now about the basic language of statistics. And by the way, that little arrow that popped up there, what that represents is sometimes when we're in statistics, we want to do a sample of the answer the question about the sampling to draw a bigger conclusion about the population. So we're going to sample statistical data from, in this case, my section of students to draw some conclusions about the parameter that we're looking at for the entire population. And that leads into this topic and discussion about descriptive statistics, for example. There's two different branches we're going to look at: descriptive statistics and inferential statistics. So let's look at those two primary terms. First, let's look at descriptive statistics. Using measurements such as mean, median, mode, range, standard deviation, we can describe a variable for a particular data set. So in our example, we can look at descriptive statistics to describe GPA students in my section, Dr. Vietz's section, or the entire population if we want to. Just remember though, measuring mean, median, mode, range, and standard deviation on the entire population can be costly and almost nearly impossible actually. So let's talk now about inferential statistics. Let me get the little circle popped up there. So imagine trying to measure the descriptive statistics for all MBA students across the U.S. Who are taking statistics right now. So all MBA students across the entire U.S. taking statistics. Measuring it here on our campus would be probably fairly easy to do, but across the whole U.S. it might be impossible. And even if it is possible, it's likely very costly, even if you could do it. Inferential statistics helps us solve that dilemma by measuring how well the sample data represents the population. So in this little example, if my section is a good representation, let me get my cursor going here. So if my section is a good representation of the overall population, then we could hypothesize that the improvement in the GPA resulting from how I teach, etc., in my section, we could hypothesize that it will result in improvements in the GPA of the entire population, in this case the entire campus, where we're at, all MBA students who are taking statistics. So listen, in this little example, hopefully you're starting to see the connection between descriptive statistics, which really works on just a single data set, and inferential statistics, which connects the data sets together. It gives us an idea of how well, for example, this sampled data set represents the entire population. Okay, more to come on that, but let's hit chapter, as we go throughout the rest of the book, let's hit chapter 2 briefly. And chapter 2 touches on just some basic presentations of two different kinds of data types, if you will, two different ways to represent numbers in this case. But we have categorical numbers, which are categories of numbers, just like it sounds. And examples would include, hey, if you're going to divide male and female, then there's the category of gender. How many are male? How many female? If you do by race, there's African American, Caucasian, Asian, etc. How many of the people in a population or a particular data set, how many belong in the Caucasian, the African American, the Asian grouping? And what about reasons people quit their job? How would the data look if it was categorized by personal reasons, don't like the boss, don't like the drive to work, whatever the case would be. Those are examples of categories of numbers. But there's a second data type, and it's numerical. Numerical data can also be grouped by ranges. So we saw, numerical data can be grouped by categories, but it can be grouped by ranges as well. So for example, students by GPA. So there are 100 students in this range from 3.86 to 3.90, and there's 20 students 3.96 to 4.0. All right, that's an example of a grouping. How about this? Speeding tickets by year. This is not actual data, of course. I'm not owning up to this. But for example, maybe somebody had 3 tickets in 2015, 2 in 2016, and they didn't learn their lesson and they're back to 3 in 2017. That'd be an example of grouping data by ranges, grouping numbers by ranges. Now, this is just a basic description of how we identify numbers, and we can break it down even more. But you know what? In business, these two breakdowns work for the majority of our decisions. And let's talk next about the other topic in Chapter 2, and then we'll wind it up here. Charts. Charts are everywhere, and I think sometimes they're needed because charts do communicate great information, but sometimes they're overused, and worse, they're used improperly. Use charts carefully and with purpose. I have a short video in the Attend section encouraging you to see charts differently from here on out. But just know this, you must question every chart you see because fake news is everywhere, and just because it's on a chart doesn't mean it's right. Okay, let's wind it up here. Discussion lead posts are due on Thursday, 11:55 p.m. midnight, but not after midnight. Discussion follow-up posts are due Sunday, 11:55 p.m. Quizzes are due Sunday, 11:55 p.m. Assignments, same thing, Sunday, 11:55 p.m. I hold virtual office hours on Zoom. I use Zoom, and you can look at the intro page and find my Zoom connection there. But I hold virtual office hours on Tuesday evenings from 7 p.m. to 7:30 p.m. your time out there, Pacific time. All right, please be sure to watch this week's devotional and catch all the required Attend videos on those tabs and everything. And listen, remember, God is on his throne. Always has been, always will be. You guys have a great day.